theorem, if ax is equal to bx into qx plus rx with degree of rx less than degree of bx, then the greatest common divisor of ax and bx is equal to greatest common divisor of bx and rx. For proof, we invoke the same method we used above by showing that the set of common divisors between ax and bx is same as the set of common divisors between bx and rx. Extending this method, we are just looking for the same process. Ax is equal to bx into qx plus r1x, and again here bx will be divided by r1x, and bx is equal to r1x into q2x plus r2x. Same r1x is equal to r2x into q3x plus r3x, and rn minus 1 into rn minus 1x is equal to rnx into qn1 n plus 1x plus rn plus 1x, and rnx is equal to rn plus 1x into qn plus 2 into x, qn plus 2x. Here quotient is the function of x, remainder is the function of x, divisor and dividend is the function of x. Then we have GCD of ax and bx is equal to GCD of bx and r1x is equal to GCD of r1x and r2x, and so on, that is equal to the rn plus 1x, the final non-zero remainder. Here is an example. Find the greatest common divisor of x4 plus x cube minus 4x square plus x plus 5 and x cube plus x square minus 9x minus 9. Using the polynomial division, we find that x4 plus x cube minus 4x square plus x plus 5 is equal to x cube plus x square minus 9x minus 9 into x plus 5x square plus 10x plus 5. The next we have to divide here x cube plus x square minus 9x minus 9 by the remainder here 5x square plus 10x plus 5. So we find x cube plus x square minus 9x minus 9 is equal to 5x square plus 10x plus 5 into x upon 5 minus 1 upon 5 plus minus 8x minus 8. And finally we divide 5x square plus 10x plus 5 by 8 minus 8x minus 8. You can see this will be divided by this, and we find that 5x square plus 10x plus 5 is equal to minus 8x minus 8 into minus 5 by 8 into x plus 1. This is the final non-zero remainder. However, remembering that the greatest common divisor of two polynomials must be monic, and we get the right of the minus 5 by 8 here, the coefficient in the term, and determine that the greatest common divisor of x4 plus x cube minus 4x square plus x plus 5 and x cube plus x square minus 9x minus 9 is equal to x plus 1. As a quick verification, we note that x equal to minus 1 is the root of both the polynomials above. So we now move on to the same contest style questions that involve the Euclidean algorithm or the division algorithm. In many mathematical contests, if you are facing the challenging problems based upon the division algorithm, you just have to go through upon these concepts and the application of the algorithms, and you have to understand this concept from the very basics, and also you have to do some important problems which is relevant to this concept. Here there is an example. What is the sum of all integers n such that n square plus 2n plus 2 divides n cube plus 4n square plus 4n minus 14? So using division method for the polynomials, we find that n cube plus 4n square plus 4n minus 14 is equal to n square plus 2n plus 2 into n plus 2 plus minus of 2n minus 18. In order for n square plus 2n plus 2 to divide n cube plus 4n square plus 4n minus 14, it must be it must also divide the remainder. N square plus 2n plus 2 divides minus 2n minus 18. The only way that this is possible, either when the absolute value of minus 2n minus 18 is greater than or equal to absolute value of n square plus 2n plus 2, or minus 2n minus 18 equals 0. In the first case, the inequality only holds minus 4 is less than or equal to n and n is less than or equal to 4. It means n lies between minus 4 to 4, including minus 4 and 4. We test all n within this range and determine that the values of n which work are n equals minus 4, minus 2, minus 1, 0, 1, 4. In the second case, we additionally find that n equals minus 9, that works, and therefore the sum is minus 11. Same in this example, what is the largest positive integer n such that n cube plus 100 is divisible by n plus 10. So for the solution, n cube plus 100 equals n plus 10 into n square plus an plus b plus c, and which is equal to n cube plus n square into 10 plus a plus n plus b plus 10a plus 10b plus c. Equating the coefficients yields 10 plus a equals 0, b plus 10a equals 0, and 10b plus c equals 100. And solving this system yields a equals minus 10, b equals 100, and c equals minus 900. So therefore, by the Euclidean algorithm, we get n plus 10 equals GCD of n cube plus 100 plus n plus 10, and GCD of minus 900 and n plus 10 equals GCD of 900 and n plus 10. The maximum value of n is hence n equals 890.